When I was a child, I was in fact interested in science from the age of about 10 years. So not specifically astronomy, but science. So I was really a fan of quite different geophysics, plants and so on. And so when I was obliged to start to do a choice at the university, it was for me very difficult to choose between mathematics and physics. So for the first year, I chose both. After, I have to choose one, and I chose to do studies in physics, theoretical physics. And when I finished in the 66, in fact, it was quite easy to get a position of PhD student because every place, laboratories was increasing, recruiting young people and so on. And it was a little bit by chance that I chose astrophysics because on the same day you have several opportunities, different in statistical mechanics or the different domain. And I said, okay, astrophysics, I will go and see if it's interesting. And I chose to continue and do my PhD in that domain. In theoretical astrophysics, it was related to the problem of spiral waves in spiral galaxies. You know, if you're looking at a nice picture of a galaxy, you have sometimes two big arms. And I did my PhD in this domain, absolutely nothing related to planet or velocities. And this arrived only later. I'm not sure to have a specific moment where I start to say, I will do my full life in the domain of science. I believe it's a responsibility of a very good teacher. I had at some moment between 12 and 16 or something like a fantastic teacher in science, doing experiment, extremely stimulating. So it was not a moment, but the contact with this man having really stimulated the interest of myself, but also all the younger colleagues. At some moment, he tried to show us some chemical reaction with chlorine. I don't know the English word for chlor. It's a very dangerous gas. And probably today it will be completely forbidden to do this kind of experiment. So he said, oh, it's a little bit dangerous, so I suggest to go outside in the backyard and to do the experiment outside to not smell the chlor. And he did a quite fascinating experiment, putting some copper inside this gas to show that it starts to burn and things like this. And also we did quite a lot of outside visits in the forest to see flowers, to observe it. So this is the important moment. Maybe I can suggest one aspect of this relatively old professor. During his full life as an elementary school teacher, he was continuing to do his own research at home. He was studying the nematode. I don't know what it is. This kind of nasty worm you can have inside your body. He was a renowned man in this field. And for us, it was very impressive to see this teacher having at home continuing research, receiving some dirty water from any place in the world to identify new species of nematode. Eventually, I have not chosen to study nematode, but extrasolar planets. I believe science is one very fabulous way to satisfy your curiosity. I still have the same curiosity today. When I'm reading some journal like equivalent to the Scientific American or General, it's so fascinating to see the huge diversity of the work going on in different domains of science, geophysics, archaeology, medicine, so on. So for me, it's better than any fictions. So I still continuing to the same interest for this kind of research done by colleagues. And here, this is a good opportunity to meet people working in different domains. And I love this. Curiosity is the most important point to be a scientist. If a student is good enough in all the basic tools of science, mathematics, physics, and so on. And he loved to study natural problems, to see what kind of very unusual phenomena exist in the nature. See why it is like this. Sometimes you are looking at the sky and you have some clouds and you see some bright spots apart from the sun. Why it is like this? So if he has this kind of mind, he could do science. I was appointed as a professor at the university during more than 20 years. So yes, I believe he enjoyed. And okay, I have to do some mandatory course in astrophysics, but in addition to this, I have the choice to teach some kind of different topics at the master degree. So you can choose. I would like to learn a little bit more in this domain. So you work to prepare the course, and no, I like to do it, yes. I'm very proud that I had, I believe, 18 PhD students in my life, and I still have very good relationship with all of them. And I was very proud that during many, many years, all of them got a position in science and continue to work in this science. And this was part of the pleasure of the Nobel Prize announcement that a few days ago we have a special celebration at the observatory in Geneva, and some of my PhD students went from Chile, from South America, from Brazil, from south of Italy, to participate to this celebration. So I believe, yes, it's good, good friends. I don't know how we have to select the people, because it's not always because they are absolutely extremely good at the universities they will be the best. I believe it's how to select. Sometimes you believe that they will be extremely good, and some it's not so good, and sometimes you have some absolutely fantastic, asking the good questions and so on. I mean, we don't have a checklist to select people. After, we have to try and see. Yes, Didier was one of my undergraduate students first, and then after he did his master thesis with me in the domain related to the spectroscopy and things like this. And then after it was the time of the PhD, so he chose to continue with me as a supervisor. And it was just the beginning of the collaboration with some French colleague to build a new instrument. And it was a good opportunity. I asked him if he would like to collaborate to this development. And it was the start of his long-term collaboration with him. And he developed part of the software to analyze the signal we receive. And so and then after it was the time of the success at the end of a few years. Before his PhD, it was the discovery of the first planet. And for him, it was evidently the start. He started in this domain, it's evident. And we have continued to work together during several years. And still today, we have some collaboration. Not only is part of the time in Cambridge, but also part of the time in Geneva, and we continue to collaborate. In principle, this is one of the most important points in science, to be prepared to the unexpected. Because if you are not only working on what you almost know before, it's not the way to do progress. So you have to always to be prepared to the unexpected. And when we start the program to search for, at the beginning the program was to search for low mass companion to solar type stars. So it was mentioned brown dwarfs and extrasolar planets. Brown dwarfs were very small companion, stellar companion, having a mass too small to ignite and to start nuclear reaction. It was not planned. But, and at the time, nobody knows what could be the period for this kind of objects. So in some sense, it was a chance for us, because we have adapted a rhythm of measurement adapted to never kind of period, either period. And then it was a chance because we discovered an object with a period of only 4 days. If we have been started only from the theory, the period of planet will be more of 10 years. We will have done quite sparse sampling of measurements. So the fact to have some kind of open eyes was a chance for us. Part of these doubts is normal discussion in science. If you have when you have new facts, I believe you have to be sure to analyze if it's really strong. And you have to remember that the first planet is a giant planet, like about Jupiter, but with a orbital period of only 4.2 days. And the theory at the time said that we cannot have a giant planet with a period shorter than 10 years, because you need to agglomerate ice particles, and ice particles do not exist close to the star. So it was a discrepancy by a factor 1,000 with the theory. So I believe it's evident normal discussion in science where you have a so big discrepancy with the theory to be a little bit cautious and to not. So I believe it was only this period for me was not so stressing. It's not true. I believe it was the period to say what could be the other explanation. What could be maybe is it a rotating star with magnetic activity? Is it a pulsation and so on? So it was, for me, it was only part of the normal discussion in science. You have something, you have to understand what could be. And then after, we have decided to postpone the announcement by 1 year, to wait the next season, to repeat the measurement, to check if everything was still there, the same period, the same amplitude, the same phase, and so on. And it's only the first week of July that say, no, the only hypothesis to explain this is a companion. Low mass companion, planetary domain. So we start to write the paper. I knew that many years ago, I've been nominated for the Nobel Prize. But you know that I was not the only one, so several hundred people was also nominated. So I was not surprised to receive anything. Okay. And so I decided with my family, so we don't mind all this. So we take vacation in